So I was saying that Earth Investigations program at Journalism Fund includes these kind of trainings where we try to discuss issues and help journalists develop skills which are relevant for conducting environmental investigations. And of course, most people know Earth Investigations because of our Environmental Investigative Journalist Grant, which is open to cross-border teams of journalists who want to investigate environmental and climate issues which are relevant to Europe and European audiences, even if the actual action or problem is located elsewhere. And certainly today, let's say the global commitment to sustainability and environmental protection is growing, and it's much higher than it was a couple of decades ago. But at the same time, climate change, biodiversity loss, greenhouse emissions, deforestation, pollution, you name it, pose significant threats, and some are actually accelerating. And while governments, corporations, and communities are recognizing the urgency of these issues and are taking steps towards more sustainable practices, it is still the role of journalists to uncover many issues. And we believe that data journalism plays a crucial role in this landscape and helps show the complexities of environmental issues, add clarity, precision, uncover patterns, and track changes over time. And of course, present compelling narratives, drive public awareness and policy action. And this is where what I'm most concerned with as impact manager for the investigations that are published with our support. And we strongly believe that data journalism not only informs the public, but also holds accountable, empower, and ensures that environmental policies and initiatives are grounded in evidence. So I hope that the use of satellite images will enhance your ability to cover hidden stories and monitor changes. And that's why we invited Gustavo Faleiros and Kuang Keng Kuek Ser today. They both work at the Pulitzer Center. Gustavo Faleiros is the Director of Environmental Investigations for the Pulitzer Center. He coordinates the Rainforest Investigations Network and is based in São Paulo, Brazil. And many of you know that he launched Info Amazonia already more than 10 years ago, which is then grew and became a very important source. And Ken is a digital journalist and data journalism trainer, and he's based in Kuala Lumpur, Malaysia. Thank you, Ken, for working on your evening hours for us. And he's the founder of Data and a training program that helps newsrooms integrate data journalism into daily reporting. So Gustavo will be mainly in charge of today's session, but Ken is also here to ask any questions. You can ask your questions in the chat, or you can raise your hand later when we switch to the practical part. And now I give the floor to Gustavo.
Thank you, Anna. Hello, everyone. It's a pleasure to be here. As Anna was saying, we are having a lot of overlaps in the kind of work that we do on supporting investigative journalists. That's why we decided to do this joint sessions on data journalism using geospatial analysis on environmental investigations. That's the core of the work that Keng and I do at the Pulitzer Center. We have a unit that we call the Environmental Investigations Unit, where we support journalists doing work in the rainforest and also ocean investigations. And a lot of what we do is based on these methodologies that we will share in these two sessions with you. Today, I'll be covering let's say the basic knowledge and tools that we use to assess satellite imagery and to start doing geospatial analysis. So we're going to have some hands-on exercise with 3 tools: GoogleEarthPro, which I believe many of you know, PlanetExplorer, that has been very useful for some of the investigations that we do, and Sentinel Hub EO browser that also brings a lot of the free resources that we use. Next week, Keng will cover even more advanced skill, which is using QGIS. I invited him to share some of the tease you with some of the exercises and knowledge that we will have next week. But for starting, I would like to do a little icebreaker. first, it would be great to get you to use the chat and ask questions. In both sessions, Keng and I will be here rotating on presenting and answering questions, but I would love to know more about your work if you want to share something on the chat. But I usually start these sessions, these trainings on satellite imagery, asking you to think about a place or a location that you would like to investigate, and that's useful for the exercise that we do in the second half of this training. I will start presenting some of the concepts that are behind the geospatial analysis, but in the second half, we'll do a lot of the practical thing. But if you allow me to ask this as an icebreaker, what would be a place, like that you would like to investigate, or even a place that you have close to your heart? That's useful as well. Some place that you, like you have some memories. I usually think about the city of my grandma, but if you think about this place, how would you tell the story of this place? How this place has been changing over the years? Like what kind of indicators, what kind of observations you would bring to someone to tell how this place has been changing over the years? Has the vegetation has changed, or a river that didn't used to flood is flooding now? These kind of things, or like an investigations that you want to a place that you want to investigate. Is there any evidence of deforestation? If you keep this in your mind, or if you want to share in the chat some of the places that you would like to look, you can actually apply this by the end of this training using the tools that I'm going to share with you. So welcome again. If you want to, I need the permit to share, just to start sharing my presentation here. Good. Start. Okay. Can you see my screen?
Yep.
Yes. Good.
Yep. Now it's full screen.
All right. So let's start with the presentation. So why we use geodata in journalism? And I should say, like, for me, it was a very natural start, because I wanted exactly find evidence of deforestation in Brazil. So I've been mostly covering, before joining the Pulitzer Center, issues related to deforestation in the Amazon. So for me, it was a natural thing, like a natural request to find evidence of how things have been changing. Again, so my big character, the place close to my heart, is the Amazon. And my question was how places in the Amazon have been changing over the years, or being degraded by forest fires or big infrastructure investments. And the satellite imagery helped me to do exactly this, finding insights to the stories, finding the stories. This is a common question that we get, how I can find a new story, an insight for an investigation using satellite imagery. And actually, you can get some of those, as you will see. Also, fact checking is something that you can do with satellite imagery and geodata. And why not using this for illustrating, doing visualizations for a story, helps you to do compelling stories. One thing that we learned over the years, and with this work that we're doing with the Rainforest Investigations Network, is that geodata or satellite imagery helps you to tackle a very difficult issue, which is dealing with large scales of space and time. So if you want to tell a large story of this territory or this place, how they've been changing over the years, as we can see on this image that we're using in an example, like 40 years of data, this satellite imagery actually help you to visualize and to give a very compelling presentation to this large scale of time. And sometimes also, if you're dealing with large spaces, like as I was saying, like the Amazon is huge, but I want to show how this ecosystem have been changing. This kind of data also allow you to bring a summarized way, or like a compelling way. So it's very useful for the environmental reporting, but not only, you can use for other issues as well. We've been seeing a lot of use of geodata on conflict reporting, as we've been seeing in the recent conflicts in Ukraine and Gaza, people using a lot of satellite imagery for fact checking and doing visual investigations. But here we're focusing on the environment. Let me start with the basics about how remote sensing works. So when we talk about remote sensing, we're talking about like aircrafts in the space or airplanes that are capturing some kind of data. For the sake of the work that we're doing on environmental reporting, most of the data that we use are coming from optical sensors, which means that our sensors that are aircrafts or satellite capturing wavelengths or radiation to generate an image. So as you can see on this illustration, what we're calling here passive remote sensing is basically an optical device that is capturing the light that is reflecting from the Earth. So we can get and different features of the territory, like a building, a road, water, or forest, have different wavelengths, and these sensors capture that. But also you have what we're calling active sensor here, which is satellites that emit their own wavelengths and capture the reflection. So the classical or the most used of this kind of sensors for our work, it's called LiDAR. It's actually used in airplanes, and they do like overflights in forests or other areas, beaming a laser jet in the territory, and then the aircraft captured the reflection of that. It's very interesting because it generates like 3D features of forest, has been using to do a much more detailed analysis, for example, of forest degradation. We have deforestation and degradation. Degradation is much more difficult to capture. So LiDAR is a good example of a other sensor that is not optical. So the way it works, like satellites can really capture pictures as the way we see when we take a picture. So which is like this blue, green, and red color bands, but also depending on the sensor, it can detect radiation. That's very useful. For example, when you get infrared radiation to detect forest fires or other changes in vegetation as well. So we can use these different wavelengths for doing analysis. We usually end up using what we call like the true color or natural color, because that's how the picture looks like, and you compare the before and after, which is a classical in journalism already. You show how things have changed over time. But when you dealing with a software like PlanetExplorer, you actually can play with these 3 bands of color, blue, green, and red, to create some design in your pictures or to highlight a feature that you want to highlight. And we'll see when we're using your browser that sometimes you can play around with these bands and getting a better view of some of the features for vegetation. This next slide actually show that. So we have the natural color or true color, as you see, like it's close to the human eye, how we would take a picture if we were flying in the space. So you see that. But if you use what can be called like the false color or like the different bands for doing analysis, this NDI is like normalized deviation vegetation index. You get a highlight of the changes in the vegetation, and you get to see better the deforestation than you would see with the natural color. And same principle applies sometimes when you use the infrared band and you see like better the burn areas, or if you use another filter that's called the moisture, the index that we're gonna see also in your browser. You can see better the concentration of moisture in the soil, so you can see where there is more wet forest than dry soil. So it ends up being useful to play around with these color bands. So what you can do besides, like just comparing, doing visual comparisons with this geospatial data. So you can play around with this three dimensions, as we say, of geospatial analysis. Let me just a little bit here. So when we're starting to do the analysis, you want to think about the resolution that you will apply to your analysis. So the first question that I ask you, what is the place, what is the location that you want to investigate? You can start thinking about what is the resolution that you want to look at. It can be a very local place. You even can look at like a building or like just one city or like one protected area. You can go up as regional to look as like a state or a province. Go up to an ecosystem, as I was saying, like the Amazon or a specific water basin. And even when we're talking about climate change, we have remote sensing or geospatial analysis that looks at the entire globe. Mean temperature of the globe, or the main currents and El Nino effect, which was something that we were discussing a lot here in South America this year, requires this kind of a global analysis. So think about, when thinking about the place that you want to investigate, what is the location, which is basically like what is the zoom that you're choosing for investigate. Then think about the time scale that you would apply to this analysis. What is the frequency of an event? For example, when we're talking about floods, how often the floods that we are facing are happening. So when you look at the frequency, you can also think about an environmental disaster that has just happened once, and this frequency is it's an anomaly on an average time scale. You also can apply the duration, how long these events are happening. I'm just thinking again in floods, because we're having one of the longest floods in a territory ever happened in Brazil. I don't know if you saw the news about the south part of Brazil that is having a flood that is lasting for a month. So imagine like a large territory, almost a third of the state covered by water. So more and more, as we're dealing with these issues of extreme events, we can ask these questions for the data, like in getting a very precise measurement. And of course, the changes of time scale, like I was saying, like when you're comparing the before and after, you get a lot of stories. And that's one exercise that we're going to do today. How was this place 20 years ago? How is it now? That usually brings some insights for us. Finally, you can think about the spatial dimensions, like the distance of something, and that also can generate stories. I'm thinking about one story that I worked during the pandemic where we measured the distance of hospitals from indigenous territories in the Amazon and calculate what is the average distance that someone living in indigenous territories had to travel to get to a hospital during the pandemic. And the number was like much higher than those who were living in cities, and that became the story. You also can measure area, of course, the reduction of an area, of a protected area, or the size of a deforestation. And the intersection brings a lot of insights as well. I'm just thinking about a recent tool that was launched by Environmental Investigations Forum. I think it was supported by Journalismfund, if I'm not wrong, like how protected areas and communities, territories in Africa intersects with mining concessions. That's the classical investigations that we do also with RIN, how, like farms or certificates, like land certificates, intersect with indigenous territories and protected areas. And then you can also intersect the deforestation. So this kind of an overlay, like of data brings a lot of insights, and the more you can get specific, more stories I think you get. Finally, perspective is something that you have to do all the time. Like this size of deforestation is equal to the city of New York, or measuring the area of different things and comparing them gives you a perspective of how big and the scale of the environmental events that we're talking about. let's jump into the spatial resolution of satellite imagery. So I'll show you pretty soon a list of providers of satellite imagery, and that is the, like the standard that you can use to decide which kind of imagery you're going to use. So we have low resolution, which is over 60 meters per pixel. So when we talk about resolution 6 meters per pixel, it's basically you're thinking about that pixel, that square, and each side of that square is going to be equal to that that distance. Like, so 6 meter pixel is equal in real world to 6 meters that you're looking at, and then you're going more and more to a higher resolution. So lower resolution, I cannot even think what would be the satellite that we would use now that have lower resolution, even only if you want to really look at the large scale geographies, you would use something like that, because most of the tools that we are using now are using medium to high resolution. So median is Landsat, Sentinel have 10 meters to 30 meters, and you already get a lot of insights, especially, or unfortunately, in areas like we work that have large deforestation, so you can actually see those changes using medium resolution. So Landsat is the satellite that has the historical series that very useful for us, because they're getting to their 9th edition. It's the first optical environmental monitoring satellite launched in '73 by NASA, and still have a kind of the same pattern of adding to the same database, so you can compare. A lot of the tools that are out there, like Google Time-Lapse, are based in Landsat. So more and more through this partnerships, we're getting access to high resolution and even very high resolution imagery. High resolution, as you can see, 3 meters to 5 meters, you can get using PlanetExplorer, which we invited you to apply for the NICFI, the Norwegian satellite program. Level 1 allows you to use base maps with this kind of resolution, but they have also another grant which you have to apply that allows you to go to the very high resolution and daily scenes, and these are under 1 meter per pixel. So that kind of image really allows you to get details on the ground, and I'll show some examples where you mark some features like buildings and even trucks sometimes, or like a small patch of forest that you want to show. That's very, very useful, but not very easy to get. Here's the examples of how things change in resolution. As you can see here, a comparison of the resolutions using Landsat. So you see what is the median resolution of 30 meters. We're looking at Iceland here, so you actually can see the features. And as you go up on 10 meters, you just see basically the pixels. 300 meters, you just see almost nothing, just like the pixelate imagery, really. Here's an example of a median resolution that we use a lot, Sentinel-2, which is 10 meters. So for this, this is Venice that we are looking at. You see something, you probably would have to zoom out to do it, to use it as a visualization in your story, but it still, suppose that island here in the middle get flooded, you still would be able to see it and use for some analysis. But look, when you get to high resolution, like which is less than 1 meter. So this is the same, like look of Venice, to which this level of detail when you get to high resolution. So the providers of high resolution, like Airbus, Maxar, Digital Globe, they usually paid. Sometimes they provide, when there's like a natural disaster, these images through Google Earth. And so it's good to, there is like a listserv that you can sign when Google Earth announces what kind of imagery they're uploading regarding some extreme event. But usually you have to have some partnership to get those. I'll talk more about it. Here's some examples of things that we use using very high resolution and how it helped us. This is a story in Malaysia where there's just one very small patch of forest left in a palm oil plantation. And that was exactly the topic of the story, trying to show that the investors were just complying with the very little condition of the the environmental assessment or the environmental license, which was preserving part of the forest, but that high resolution imagery just showed the absurdity of what they were doing, this very little patch. Another example that I bring, this is a very good story that we did in Brazil, showing that a company that was supposed to not be working, that's called Gana Gold, it was actually working full speed in the state of Pará. Started by Yuri. We have a good partnership with the NGO that's called EarthGenome. So they're using, again, Airbus imagery, in this case, identifying every feature of the mine, including the airstrip, you know, like where they take the gold out of this area, you know, like all the wastewater. So that's something that you can do with satellite imagery, you know, like actually identifying the features and doing this kind of visual things. Here, the summary of what kind of data you can get for free or not free. Most of them are free here, and that's what we're going to explore with Earth observation satellites. These optical sensors that goes into the satellites. So we're talking about satellites like Landsat, Aqua, and Terra from NASA that have this medium resolution. So you can get really good imagery through your browser or the NASA catalogs that are always changing, but usually very good. Earth Observatory, NASA World Viewer, or Landsat Viewer brings a lot of this imagery for you. Google tools like Earth Engine and Time-lapse also, and the GoogleEarthPro that we've been using a lot of this imagery as well. And you can do print screens or download directly from there, no problem. We have a lower resolution, a better resolution, but it's still medium resolution with the Brazilian Chinese satellite called Sivers, and also the Indian satellite ResourceSat. ResourceSat has different sensors in it, but you can get it for free using the INPE, which is the Brazilian National Space Agency. Not being patriotic here, is actually a really good imagery catalog for Earth observation. So if you get into it, you will find both the Chinese Brazilian satellite imagery and the Indian satellite imagery as well. When you're, you know, like doing complex investigation, you might want to go to every single repository to see if you can find something. That's why we're listing all of them. We'll use your browser, which brings the European Space Agency catalog. Sentinel-2 is the optical sensor that we most like to use. Actually, Sentinel-2 is the satellite sensor. I think it's called the LCA. I forgot the name of the sensor itself, but Sentinel-2 is the reference for us to find this 10-meter satellite. Then another thing that we're going to use today is the Planet satellites. Have like this 2 to 3 meters high resolution, and you can get it via the NICFI access. So that's why we asked you to apply for the NICFI satellite program level 1 that everybody can actually access. They have another one which is called level 2 that gives you even more data, but that is a longer application process. But the one might be useful already. And then we have like a very high resolution, which is under 1 meter. That is all this Airbus Maxer that is on Bing, that's very powerful, and Digital Globe. All these three, they're really, really good for doing specific investigations. I've been seeing Maxer releasing a lot of data for conflict. I saw Maxer data being used a lot on the coverage of the Ukraine conflict. We have been using Airbus more than anything because we have this partnership that allows us to access it, but you also can pay. They're usually very expensive, and also I can say is that for them, for these companies, to work with journalists is a big advantage because we usually use not much of data. We use for illustrating things, and they very open to release data for journalists because it's a promotion for the thing. Imagine it, you know, having their image in the front page. So I would advise, if you want to use this kind of imagery, very high resolution, to seek the companies directly and explain your work, I think you would get some access. So thinking about already on how to build the stories and teasing you a little bit about the training that King will be leading next week. Once you get the satellite imagery, and the data that you would like to work, it's very important to bring this, what we're calling the layer mindset. Remember, again, I'll refer very often to this initial exercise of thinking about the place close to your heart, like what are the indicators or the layers that you would use to tell the story of the change of this territory. So it can be like the rate of deforestation, the consumption of water, what else? Even like the income of a region, levels of education. As long these layers have some kind of special spatial data, some kind of a location in it, you can actually pile them, overlay them, and compare them, and getting some stories. Remember I was saying about the intersection. So when we start intersecting these layers, we extract a lot of insights. How, like mining concessions are invading indigenous land, how a river within a specific area is reducing. So things about when we start thinking about the stories, what kind of layers you will pile and overlay to getting the insights that you need. I will show you some examples before we start with the practical thing. Just checking on time. I think we're doing good. Let me start opening. So I'm gonna share this these slides with you, so we will have access to all these links. But I will just go over on some of them just to show you how it works. So we recently published this story with the Africa Report. It's an important magazine that covers the entire continent. The journalist that worked with us is called Muzinguzi Blanche. So he wanted to prove that there was a lot of Congolese, DRC, Democratic Republic of Congo timber being smuggled through Uganda and reaching also Kenya. The story, I should say, it was not unknown. It was nothing that it was a secret. A lot of people knew that this was happening, but the hypothesis needed to be really proven with satellite imagery, with data, to be stronger. So there was a lot of talk about this, and he made it. Like he really did a great work. So the thing that he would do, it was actually doing some field work, going and identifying areas. Like, let me get to the point. So we're talking about the border between DRC and Uganda. So he went to these three places, traveling around through the border and seeing things with his eyes, and so like, well, there's like a timber patio here, listening from people what was going on. And he would go back to his office and work with us to identify how these areas were transformed. So you see like the Airbus imagery from February 2020, and you then see the areas that were transformed into patios, like for storing timber. That was, like thing that he brought the information from the ground and got back to the office and found the satellite image that proved what he saw and heard on the ground. So you see the patios here. The story is really well done. I invite you all to spend some time. It's a series of 4 stories where he gets deeper and deeper on how this is happening, from the construction of the patios to the border control, up to the officials that were allowing this to happen. And it's interesting that when you get this level of evidence and you prove with your investigation, you actually get to be heard. So the Minister of Environment invited him to a meeting and asked him to basically present the story for him. And the minister said, yeah, well, okay, we need to do something about it. And he announced that he demands more control in the border. Let's see if that's gonna have some real impact in life, but we're already brown with with the fact that the minister invited him for a meeting. And that happened with stories that we did in Malaysia, in Brazil. I believe a lot of you are investigative journalists here already, so you know how it works when you bring a very strong investigation, you get people to respond to it. Another example that I wanted to show you is this series that we did with Armando Info, a very important outlet based in Venezuela. They actually were portrayed in a long documentary did by PBS recently about the work on investigating the Maduro government. And here they did a story about illegal mining in Venezuela. Before I just scroll down here, I want to bring this other aspect that is behind this story, which is the thing about having an effort that lasts over time. So I talk about like using geodata for dealing with the challenge of time scale, like how things has been changing for many years. There's another aspect of this, which is very interesting, related with the work that I've done with InfoAmazonia, is that once you're covering a territory, it doesn't mean that you're going to do one story. You will have to be doing stories for a long time to see how these things will be transforming over time. So it's natural for us as investigative journalists to want to monitor things. So you will see like more and more journalists creating these databases, like I was saying, the example of Alexander Brutel, who created the Mining Watch in Africa with Environment Investigations Forum. It's not that he's launching a story, he's launching a platform to monitor mining in Africa. And we had this instinct when we saw this story from Armando Info that we needed to create a database to monitor illegal mining in the Amazon for a longer time. So we launched this thing here, which is, I'm seeing it's in Spanish. Let me just reload to get the English version. No English version yet. I'll change it here. It's called Amazon Mining Watch. So basically what this tool does, it's applying a machine learning model to go over satellite imagery of Sentinel-2 and medium resolution, which has a good frequency, and identify new areas of mining. So these yellow things that you see here are all mining scars in the territory. So when you get close to it, you can see what the machine actually identify. Again, we're doing this with a good partner with this Earth Genome, this NGO based in the US. They are the ones who developed the model, but the concept came from us journalists who have I would say the right questions, like we know what we want to look at. So these areas are identified and helped two fellows of our cohort to do their stories. So you can get to see the latest, and high resolution imagery. You can even see like areas that has grown outside of the yellow boxes. So using this model, these guys here of Armando Info, they created this story showing that, this is the data, the red one is the data coming from that platform. What they did here, the two reporters working with us, which is Joseph Polisuk and Maria de Los Angeles, it was tagging and seeing airstrips that are close to the mines, because that's the story, showing that there was a lot of illegal actors managing airstrips in the jungle for doing illegal extraction of gold. It's a very well done story, won the award of the Global Investigative Journalist Conference last year, goes into very much details on identifying these airstrips. There's something that they did using Google Earth, like doing this kind of a visual identification. So they use several tools, and including QGIS and GoogleEarthPro for doing this story. All right, these are my examples. Let's jump into the practical thing. Any questions at this point? I'm seeing the chat just like going really, what Keng is doing.
Yeah, we are all good, Gustavo. Yeah.
Wonderful. I'm very soon we will invite you to talk a little bit more about QGIS on this slide. So what is geospatial data that we're gonna work with? So we have two kinds of data that we work with. Raster, that are basically the satellite imagery, like this, a proper photo built with pixels, as you can see on the illustration here. So you have like the several pixels creating a picture, but every pixel brings a location information. So if you get a raster file, a satellite imagery like TIFF, I will talk about the formats very soon, and you upload it in QGIS or you upload it on GoogleEarthPro, they actually go open that picture in the exact location where it is. So it's very cool for us. That's why, you know, like as we're putting here, the geospatial data is actually what can be mapped as data that contains location. And when you open in the several formats that we're going to review, you actually see it on a map. So the main difference that you need to know, and I believe many of you know, is like that either you work with raster, which are imagery, or you work with features like a point, a line, a polygon, and this is our vector. Like we learn in our math classes, you know, like several points to a line, several points to a circle. That happens in geospatial data as well. You get all these features and you build a map with it. And next training is going to be QGIS, where you happen to open these two kind of formats together and compare them. I'll invite Ken just to give you a quick invitation about why you should be in the next training and using QGIS.
Right. So the next training next week, same time, we'll be using QGIS to do some of the investigation that we have done with our fellows, right? So we are going to replicate the methodology with QGIS. So it is a very practical, hands-on session. So please make sure that you install QGIS on your computer. Give yourself ample time to do that because the installation file is like 2 GB big, right? You won't be able to download and install during the training. So make sure you have done that before the training. And we are going to walk through like step by step. I will share with you all the geospatial files. So we are going to, you know, put a polygon on QGIS, and then we're trying to find, you know, the overlapping areas between the timber concession and the protected areas and see how big is that area, right? Which is, you know, from a real investigation that we did in the DRC. Back to you, Gustavo.
Thank you, Ken. So don't miss the next training. That was like the teaser for making sure that you don't miss the next one. Let me go to the next one. So the kind of files that you will find when you're dealing with geospatial data, and mostly you will be working next week with them, opening in QGIS. But we have the vector files, as we were saying, like the polygons, the lines, the points, and so the most I think it was stable and used one. It's called Shapefile or SHP. It was created by ArcGIS, the famous paid software, which is really good but very expensive. You still can get some partnership with them, but we use QGIS, which is open source. It also loads Shapefile. It's one that comes with like a folder of data, and you need to open this folder to see all of them. You will see that when we're working with QGIS. Very useful, as well as GeoJSON. We use today KML and KMZ. They're the same thing. The Z is for the zipped file, but that is the Google format that comes with Google Earth and Google My Maps. That's where you get to open this in Google. And the name, it stands for Keyhole Markup Language, because Keyhole was the company that invented Google Earth. It was not called Google Earth until Google bought it, but that keeps still the file format name. Then you have the tables. As long as you have like a CSV or Excel file or like a tab separated value spreadsheet, as long as you have like the geospatial coordinates in this spreadsheet, you can reference them, and you can and put it in a map. So you will find it a lot of, like, for example, NASA websites, for example, forest fire data, CSV, which are light to open in your software. And also you will find other files with this GTP. I talk about like the raster, TIFF and GeoTIFF are the formats of satellite imagery that bring the location in it. So when you download it from your browser, as you see, you can find it TIFF and GeoTIFF. For reading more about the formats, I put it in an article down here. Running in just a little bit for making sure we get to do the exercises. This is something for you to explore. Here's the links of the tools that we're going to use today. PlanetExplorer, GoogleEarthPro, which I guess you already downloaded. And there's some sources to get the formats that I just mentioned. NASA Earth data, Protected Planet for getting protected areas, Global Forest Watch for global, really global forest change data, and base maps with natural Earth. And you can even find more data about climate in this other one, Resource Watch. As I said, it will have this link, so don't worry about this. I will jump into the practical part, and you will see how it works. So let's start with GoogleEarthPro. I hope you have downloaded with it. So let's open it. I'll jump to my own Google Earth and show you some features, and then we'll come back and do a little exercise with these coordinates. So the GoogleEarthPro, as we mentioned, is a desktop software. Now you can find it online as well, but the desktop is much more robust, so you should use it. So it allows you to do a lot of things and seeing, like high resolution satellite imagery. The way I use really quick Google Earth a lot is if I'm doing some field reporting, I come here and look at the place before I'll go. Another thing that I do when we're not covered a lot is to track my trip in a GPS. So here's an example of a trip. Like I use a GPS, and you can come here and actually connect your GPS. You see my Google Earth, right? Just to make sure, because I'm not seeing you.
Yes. We're looking at Google.
Okay.
Yes.
So you can connect your GPS directly on your Google Earth, and he will download a file that's called a GPX. That is basically same format as a KML, and give you the track of your trip. So this is a trip that I did on Xingu River in the Amazon. So here's like 100 kilometers of a boat trip in the river. So thinking about the layer mindset, what I will do later is actually open other files, so you can start overlaying things here, like the protected areas, the indigenous territories, the deforestation rate. So I'm looking with a much bigger scale, like did Muzinguzi in Uganda. I went to the field, looked things in my eyes, I come back to my office, zoom out, and see what was surrounding me. I have an idea of the spatial scale. What was the deforestation rate? What were the cities nearby? What were the protected areas that I was entering? Of course, I knew some of those, but it is important to use that. Another tool, and that's what we're going to use now, is the clock. Can you see it right over here? There's like a clock with a green arrow. When you use this clock, it gets you to see the historical satellite imagery. So I went to this trip for seeing the construction of this dam here. It's called Belo Monte Dam, which was causing a lot of problems for indigenous people. It was built in 2017, ended to be built in 2017. And if I go to the historical imagery and go back to 2010, I can see there was no hydroelectric power dam here. And then if I turn off the clock, I see the dam. So you can do like this before and after, if you like 2005, and how is it today, by basically using this clock. And you can actually, going only to the files, do a screenshot. If you print, it gives you the screenshot, or if you save the image, you can just get the before and after of something. So here's a place to start for doing this kind of thing. And you see down here, it actually gives you the date of the imagery. So here you're looking at 30th of December of 2003. And if I go up to here, it's telling me it's gonna give me some date here. Yeah, I can see that like 20 22 of June of 2017. They were still building the dam. So we use that for comparing. Another thing that you can do, which is cool, you can measure things. There's a ruler, so you can see, for example, if I want to see the size of the dam, I can say, like, okay, the dam has 3 kilometers. You see, I can see the wall of the dam has 3 kilometers. As I was saying, this is useful for planning when you're doing a field trip, like what is the distance of this indigenous territory to the closest deforestation, and so on. Here's the exercise that I want to propose to you. I think either Anna or Ken will help me on pasting on the chat these coordinates. So I want you to copy these coordinates from the presentation. Oops, sorry. No, that are here, and go back to Google Earth and actually do a search with it. So I actually did the search here. It's just to put it on the search box, and it will give you a location. So this location, it's not exactly close to the heart of Keng, but it's close. Well, why it's not? Yeah, it's close enough to him in Malaysia. It's, look at this. It's an illegal dumping site. So it's using 3D here. It's trying to get rid of this 3D, but it's not working so well. But all of the resolution doesn't allow you to see in detail, but this is all like garbage that is within a lake in this area. So what the exercise we want you to do is to get to this place. Let's see if you have any doubts. Just copy the coordinates, put on the search box, search for it, go for it, and use the clock, the green arrow clock, to determine what was the month when this dumping started, when they started putting actually trash in this area. Basically, you have to go back in time and finding a moment where the lake was not covered by garbage. So shall we try that? I'll just go back to Zoom to see if there's any. I know you were seeing yourselves. But let me pause sharing. Any, you can unmute. You have any doubts? And I'm seeing Paul has already found something here. Good.
I can't do the copy paste. It just says it isn't coordinate, so it doesn't work.
It didn't work? Okay. Did you get from the...
No, it says it's something like a link, and it doesn't accept it in the search box.
So do you want to try to paste just a Shift, Command, and V, because then you paste without the formatting. I think as you probably getting the link, if you paste just the value, you're probably going to get it right. Yeah.
Gustavo, we are looking at your Slack screen.
Yeah.
You want to switch that? Yeah.
I was looking at the
not your
Zoom.
Google Earth, yeah.
I don't know why. Any change?
Nope.
Nope, it's still the same screen. We are looking at the...
Yes, now they...
Yeah, now it is working, yeah.
I paused when I went to Zoom, and I don't know why it stopped it there. Nothing to hide. Okay, so as some of you put it, if you go back, like in time, you see it was not a dump site in 2011, not in 2014, not in 2017, and they started to build this lake. Like it's a mining area. So the lake started to be built in 2017. and 2019 things started to change a little bit. So here's, like you see already in September 2022 that it's full of garbage. So, and December 2021, it was not. So we have a gap of imagery that we cannot cover. So it would be ideal if we have all of them, but that's when other tools come to play. So the thing would be going into other tools. We actually tried to find the exact date on PlanetExplorer, and there was an issue of resolution. So we won't continue looking at more detail. We have another example to look at more detail, but you can see that happen as some put it here. I saw Paul first and then Ross. That happened between December 22 and September 22, 21, 22. In that year,
Gustavo?
a lot. Yes, go on.
Can you start all over again from like putting in the coordinates in the search box and opening
Sure.
up the clock historical images? Yeah. Because some of the participants are kind of lost.
Yeah, so I got the coordinates, oops. Came here on the top on the search box. Like I copied that coordinates that is in the presentation on our chat on Zoom. And it gives me this place. Okay, it's already there. This Blackwater Lake. So I'm looking at here the most recent imagery. It says like 27th of February 2024. On the toolbar on the top, there's like a pin, some kind of a polygon, a camera, a small camera. Right by the side of a sun icon, there's like this clock with a green arrow. When I click that, it gives me a timeline, which started in 8085. So I started putting this timeline back. The first imagery, as you can see, has no resolution because it's too old. But 2004, I already see like the forest. And then 2008, I can see the start of the deforestation. 2009, there's a big mining operation on the side. And start moving up, like seeing how the territory has transformed. That's how I get to see that in 2019, there's this lake built where there was forest. 2021, we'll see by December, the lake already formed. But, the next imagery is September 2022, and you see all the garbage dumped there. That's how I did it. So a way of putting this on the story would get like a previous image, save it, get a second one, and compare them.
Yes.
Gustavo, you can change the 3D feature by holding down Shift and move you hold down Shift and move your mouse. You go to the map and then you hold down Shift and then you can click on the mouse and move it. Yeah. No. The other direction. You move to the direction. Now it's 2D.
Yeah. So you can see the lake and
now it's clear. Yeah.
So there's a mining site on the side and the dumping site here. It worked.
That's a good question, Gustavo. Like how often the satellite imageries update? Is it regular?
There's no, depends on each place. They announce like a major updates, but there's not a established frequency where they update. I think they keep trying to update very often, depending on the place. They don't have like a frequency announced, not that I know. What I've seen, as I told you, they have like this Google Earth outreach team. And so it's good to sign up for their list. I haven't received recently any updates, but they have this work of bringing high resolution satellite imagery for events, extraordinary events like conflicts or like volcano eruptions, floods. And so they dump this new imagery and you can find it and download it. But the frequency is not given, not that I know. You have to really look at it. Any other questions? Should I move to the next tool? Oh, sorry. Just all right. So GoogleEarthPro is very easy to manage. So I really recommend you use it to your investigations as a beginning of your investigations. The next one we're going to use is Explorer from Planet. Planet is a private company who builds satellites. So they build satellites and platforms, and these platforms bring data that's not only from their satellites, but they in that case they promise a frequency. If you sign up for the level 1 access, you have monthly base maps, which allow you doing much closer comparisons. So 2 things that we can do here. So like a first exercise to access the base maps, you have to log in on Explorer. I will go back there. Search for this word, Roraima, which is a state in Brazil, and just compare these 3 months. I'll go there and show you how it works. Wait. So PlanetExplorer is this thing here. They usually open you on the daily scenes. You will see that daily scenes is not available for us who have like level 1 access. So you have to go here to the base maps, which is the second icon. So the base maps, as you can see, you have like mosaics of tropical areas. So that might be a problem for some of you working in. So this is the level 1. It's covering these areas here. I know it's specific, but I know many of you are also working in these areas, and you can compare month by month. So if you're looking for Roraima,
Gustavo,
yes.
Before that, Gustavo, can you click back the button back to let them see the first menu? No, back. The under base map, there's a back under base maps.
Sure.
Yeah. This is the first menu, and then which one they should click? Yeah.
The one is the tropical normalized analytical monthly monitoring. Yeah. So you have the base maps, and you see they have this different mosaics, monthly mosaics. Let's use the monthly analytic. Thank you, King. And search for Roraima, which is this state. The reason I'm talking about Roraima is because of this, just showing an image in Portuguese for you, but you know, like you have a big amount of forest fires there. So you can see the degradation of forests in this image here. And that comes from Planet. Basically, if you approach the center of the state, which is Roraima here, and you go back to base maps, PS tropical normalized, you see March, there's all these areas degraded right by the name of the state. You can see it. These gray areas or like brown areas are actually burned areas. And if you go back to January this year by just clicking on the eye here, you'll see they were not burned. That all happened in 2 months. Look, if you go back to, and then you go to February, you actually even see the smoke, a little bit of smoke here, start burning here. And if you go to March, you see a much worse scenario. There's more smoke here. This is like burning smoke. Look, you can actually see the burning smoke of the areas coming out. So this is really good imagery that you can use. And if you go to April or May, let's go to May, which is just now, you'll see that there's already rain going on. So you cannot see a lot, but April, you will see a better scenario than the previous one with the burning happening in March. So this is the more frequent imagery that you can use with PlanetExplorer and build stories that require this kind of analysis month by month. And the next exercise that I want to propose, which is here in our slide, is a search for this place here. It's called Non Tamao Wildlife Rescue Center. Same thing on PlanetExplorer monthly monitoring, the base map. And you have to ask when the deforestation happened in this place. That's very specific, because I'll give you a tip. Happened from just in 1 month, this protected area lost a big chunk of forest. That's a story that we did with Ariane. It's important, and I'll show you now, that when you get to this place, Non Tamao Wildlife Rescue Center, you zoom out just to see the entire forest. So let me show you. I need to just copy myself the name. So I copy here, go back to the search box, and I put Non Tamao Wildlife Rescue Center. It's going to fly over. You know, it says like you don't have daily scenes. So I'll go back to the normalized analytical month. The zoom out that I'm talking about is because it gets the location, it's the center of the forest. But here's the entire forest. You can see the patch, the perfect patch of forest around the city. The importance of this area is that's the biggest green zone close to Phnom Penh, the capital of Cambodia. So you see the deforestation is here on the right. So my question is, when this actually happened? So you can start moving back in the timeline here down and looking month by month, or you can click on the side and just discover when it actually happened, when that part of the forest disappeared. Should we try that? Any doubts? I actually have to go back to.
Yes, it's a little bit blurred in my my desktop.
Okay.
So I don't know what I have to change.
Did you put it on the base maps?
But it's still blurred. Yes.
Can you see the entire forest like me? You have to zoom out a little bit. Maybe you're too close.
I zoomed in. Maybe that's it.
Yeah. The trick here is to zoom out to see the entire forest. Just zoom out a little bit.
Okay. Yeah. Thank you.
It's counterintuitive, right? Like to zoom out. It's just because the location in the database is too close. So you zoom out and you see the entire forest, and then you start moving.
That's the trick.
Yeah. So sometimes it's an issue of resolution. So you start moving back. So if you go to December 2021, look, the forest is intact in December 2021. What happened if I go to January? Come on. January 2022 is intact as well. So giving up the answer, if you go to June, you will see the forest is perfect there. But if you go, if I'm not wrong, it's August. So you see it just disappeared in a month. From July to August 2022, they decided to cut down this huge path of the forest. So that's the answer. Everybody, or a big part of the team here, managed to get it? I'm not seeing you, sorry.
There's one answer that is correct, yeah. From
okay.
Nicholas.
Well done, Nicholas. Guys, questions? Is it easy to manage this? Any questions we should help you?
I think my computer's just slower.
There's this issue too. Sometimes the computers need, satellite imagery needs time to process.
Gustavo, can I just quickly add something?
Of course.
So everyone, for this monthly mosaic, right? It is actually a combination of multiple satellite imagery for one area in that month. So it is not actually the imagery of a specific day. So just bear in mind when you getting the image from this PlanetExplorer, is that because, you know, like imagery on different days. Sometimes some imageries are blocked by clouds, right? So it's not very clear. Parts of it might be blocked by clouds. So what happened for this monthly mosaic is that it combines all the different imagery in that month, and it creates a very clear image for you to look at. So you can see that there's no cloud in the image, which is unusual because in Southeast Asia, this part of the world, it is quite often cloudy, right? So just bear in mind that, yeah, it is a combination of multiple images in that month, but it is representative of that month, right?
Yeah, the story here, thanks, Kim, is this one. It's like in just 1 month, that patch of forest disappeared. So the good news is that that generated a lot of commotion in Cambodia. We think we are part of that because we had 2 fellows in Cambodia at the time. They did awesome stories about the destruction of the forest. And what happened, it was, let me show you the picture here. So the story about the deforestation, it was done while the deforestation was happening. This is a story by Anton Delgado, a fellow from Philippines that works in Cambodia. So he shows like the roads being opening, like it was ugly. It was like machines just like getting there in 1 month and destroying everything. But the good news is that the story generated the commotion, and the prime minister of Cambodia intervened and said like they should reforest the area. A bit nonsense, but here's the picture of how it looks after it was cut down. But if you go back to PlanetExplorer and start moving up to this day, like let's say April, you will see that it's actually greener now. You see, you can see it. It's greener now because of this reforestation effort. It's not the same thing yet, but they decided to replant the area, at least close to the rivers. I think you can get some greener areas. Interesting, isn't it? All right, any more questions? I'll jump into the next and last tool of the day.
There is a question on the chat. How to download pictures from the satellite in order to include it in a photographic work.
How to download it? How to get it? Okay, so you...
Yes, the question is how to download, yeah.
So you can do 2 things, as I mentioned. You can go here in Google Earth and search the place. Let me see if they have it actually here. Yeah, so here's the same place in Google Earth. They actually have a good image here. Yeah, more or less, they have like, you can see the mosaic still. If you get too close, you see like the different satellite pictures here. But you can come here depending on the area, and you use the function of save, and you can save image, and you can get to actually build a map with even title, but you can get rid of all of this. You don't need it to have all like title, legends. It's up to you to use what they give you. Like even a compass, I think it's useful. Like you see the north down here, and then you save the image as a JPEG. You can get a high resolution, as you can see, even very high, like ultra high resolution, maximum 8,000 pixels. So you download before and after. That's one option using Google Earth. The other option, it's the one I'm going to show you now, which is the EO browser. I think Planet, you cannot download, maybe King knows more than I, the JPEG of the pictures. I don't think so. I think
so. Yeah, for Planet, right? If you only have level 1 access, which is what you have now, you can't download. But what I usually do is that you can always put it on a bigger screen, and you do a screen capture. That works, right?
And as long as you give the credits.
Yeah, remember the credit. Yeah.
Exactly. For all these tools, Google Earth and Planet, credits. You put like they're putting here like 2018 Planet, and you get to use the imagery. The next one actually allows you to download the picture. So the next one that we are using, and the last one, because we are close to finish, is this one here called EO Browser. You also have to have your login. So what I want you to do, and help me on our Keng to paste this link here, is to get a polygon. It's the first exercise we're going to do of uploading a geospatial data file into a tool. And then we'll see the polygon on your browser, and you see the same area in Cambodia with Sentinel-2. And then I will show you things that you can do there in a very quick way. So your browser, which used to be a platform managed only by the European Space Agency, but I just see now that it's managed by Planet, which was surprising to me. So once you are in the Sentinel hub, and then you start exploring, you end up on this, on this platform here. Let me get to the beginning, actually. Let me just get to the beginning because it's easy. So you get to this tool here. Always starts in Rome. I don't know why. But you get to see this platform here. And what I would like you to do is to get the file that you downloaded from the drive and simply upload here. And to do that, you needed to go to this first icon under the eye, which is a polygon, and click on the upload button. And we will show you the window. I hope you've seen the window file upload that I have in front of me. And when you click it, you will get that KML file. Remember the KML from Google, to upload on this. And then when you have this file, like of a protected area, it brings you directly to the area that you were looking at, that area that is close to your heart. You can come to it. So you see they surrounded the exactly forest that we are using already with the deforestation here. And what we want to know is, what we want is to get satellite imagery from Sentinel-2 that is by default is already here. What I do is use advanced search because you can determine the cloud coverage, and it's very difficult to get zero cloud coverage, especially in Southeast Asia, as Keng was saying. So I usually put like 15, something like that. And you can search for, as you know, that the thing disappeared in July, August 2022. Maybe we can put it like May 2022 up to March 2023, something like that, and do the search. When you do the search, you get a catalog of image, you know? So I want to go back and see, for example, how was it in 2022, June 2022? And here's the thing that I mentioned to you, it's loading. It takes a while to load. Now it's taking it. I think it's because of the zoom. Here we go. So you see, I have the forest here within my polygon, right? So what I can do here, it's if I want to adjust this image, there is an icon down the polygon just to download the image. It gives me the picture of that polygon. Look how cool it is. It cuts the picture for me already just on the area that I'm looking at. And if I come to analytical, I can download it as a TIFF. And you will see that it's an important feature because then we can take this image and build the base layer on QGIS, or I can even download it as a KMZ and open back in Google Earth if you want to overlay things in Google Earth using Google Earth.
What icon did you use to get there?
So I click it on
okay.
You saw it? Like there's an image with a download sign. So you click it here.
Yes, thank you.
Yeah, good. The other thing you can do, or you should do, is click on this again, back on the true color here, you can click on these two arrows like that and add to compare. So if I add to compare, I have this image now here to compare. And I go back to Discover, and I choose another picture from 2023. Look, I'm going to choose. Now I can see the deforestation in 2023. And I put it to compare, chance, okay? And I go to compare, and I can get, you know, to do like the before and after. So I'm looking at 2023 with the deforestation. As I slide down, I can see how was it in 2022. So you can even, I think you can download it like this as well. No, you cannot download the comparison. You could just get the latest image, but you can share the comparison.
This is the, sorry, this is the same that was used for global news investigation, right? Because you showed the...
I don't know if they do. They usually, what they do is like they get the two pictures, and each newsroom has a different tool. There are different tools that do this kind of before and after. But that one, you can get the link. What I use here is more for analysis. But let me show you a different thing, which is this other icon here. Under the download of the image, they have a GIF generator. So if you click here, and they give you all the collection. You can choose two pictures. Oh, they don't have all the pictures. But anyway,
they have. So you can just I think you I just did one. You have to go to hold on. Let me find the date.
Yeah, it's because you have to do another search. You see, the search here is not comprehensive enough. But as we're finishing, I think the message is it's clear here. You can choose pictures and create like a GIF like this, and you download it. It gives you a GIF image. So it's a very useful thing for us journalists. So you just choose the image here, and you generate like a comparison and download the GIF to put in your story. I like this a lot. I've used it in some stories that I did. Any doubts about this, about the time lapse and the downloading of imagery? Because I will jump into another feature to finish. Really the last one. So remember I told you about the other color analysis. So they have something here which is also beautiful. It's called the highly optimized natural colors. So you get to see really beautiful picture, better than the true color. But there are two things that we like to use as well. One is NVDI, Normalized Deviation Vegetation Index. So this one, it's beautiful to see deforestation. You actually see all the roads and everything. So it's a different band that highlights what is vegetation and what is not. So you actually see green and not green, right? So NVDI for any kind of vegetation loss or vegetation grow as well, like plantations, it's awesome. I love this one too, that is moisture index, because guess what? Forests are wetter than non-forests. So you can see like the blue ones is where there's more water. The red one is where there's no water. So if you go back and look at the 2022 image and look at the moisture index, look what it is. You know, like it was all blue, lots of moisture. Environmental services played by the forests, and then when you get to 2023, no more moisture. That's lost. That's why we're talking like about heat clusters in cities and this kind of things. So this kind of analysis are pretty cool as well. And if you get to do, you know, like a comparison of several images, you even can get the kind of a numerical insight of how the moisture has diminished. This is the kind of thing that you can extract using QGIS from the satellite imagery. I think I will finish for here. I know it was a lot for for us. So here's our email. Maybe we can stay 5 minutes more if you want to do some more questions. Here's our emails. We're very happy to be in contact and know more about things that you want to investigate, things that we are working on. You are working with Journalist Fund and we can help. That's our mission. Let me stop sharing. I think I'm still sharing. Yeah, let me stop. No, I stopped it.
Thank you so much, Gustavo. I think Giorgio has a question.
Yes. Thank you, Gustavo, and Keng also, and Anna. I wanted to ask if I have a data set with coordinates like latitude and the longitude of some projects that are that have harmful impacts in the territory. Can I which tool do you recommend to track like a data set with a different location all over the world? So a tool that allows me to display all these places and to check the difference in time in every point in space. Is that possible?
Yes, yes, I think it's possible. What I would do to start, and Ken can complement me. If you have a spreadsheet with all these places, maybe you have the address or the coordinates of each one of these places, no matter. I would go on Google Earth and ask it for geocoding. That's an important word. So Google has, as QGIS also has, the capacity of do geocoding. It's basically get a spreadsheet and read the addresses, the column of addresses. Say like my addresses are on column J, and then the software will recognize those addresses and create, like points in the map. So my start would be mapping, generate a geodata file from a spreadsheet and getting the points on the map, and then you start overlaying things. What is I don't know what you're looking at, the pollution. You can even get like a pollution concentration, or you can get like a deforestation on each side. That's how I would do it. Ken, do you have any insights for that?
I just share a tool that I found online. So online, there are several tools that allow you to copy paste your address. It will generate the coordinates for you. Most of them actually use the geocoding API from Google Earth. So which means these are all in a database of Google Earth, but you have to make sure that you put in the complete, address. And in some countries, in some rural areas, maybe the addresses are not in Google database. Those, they won't be able to give you the correct coordinates. So just be careful about it.
And then I could, once I do this step, I could display all the coordinates simultaneously on, for example, EO browser in the way you showed.
Yes, you can do it.
Perfect.
Although your browser, I think it's polygons, right? Okay, only polygons, but maybe they allow points. I'm not sure, but try on Q. You will see that QGIS is going to be your best friend for that.
So you should come next week, and I'll show you how you can put the different coordinates on QGIS. Yes,
I'll be there.
Because then you can start putting on.
There's another question from Paul. When you enter a date and click apply in EO, it takes you back to the map view. How do you go back to the satellite imagery?
I am trying to recreate that. I'm not sure what does that mean. So you click on the date.
On your browser?
You enter a date. Yeah, that's I don't quite understand. You enter a date.
I think it's because you have to load the satellite imagery, Paul. I think this is the issue. I don't know. But
yeah, Paul, maybe just try a different buttons, a few more times. You will figure out how to navigate it, because I'm not sure what do you mean. Yeah.
Paul, maybe you want to share your screen and just show where the problem is, if you still have that window. That's an issue. If not, yeah, you can play around.
maybe he's not here anymore.
All right.
I know I'm still here. It's just that so now let's see.
Yes.
It's
We can see
because
the
of the availability of imagery.
Yeah, so part of it, as you can see over here, it's got satellite imagery, but here there's just
I think it's because the availability of image to that area in that period. I think you will need it
but
to
you
play
had the
with other
same dates.
at the same dates. So it's a
So,
loading.
I mean, you can see the date here. It's
So go back to Discover, please, on the side of Visualize on Discover. Just it's because you have one image. So you will have to either diminish your requirements for cloud coverage or increase the date range.
I see. Okay.
And you get a more imagery, and then you will get the imagery to load on that part.
Okay, thanks.
Yeah.
All right. Any more questions? If not, then thank you so much, Gustavo and gang. I think this was super insightful. And I mean, I can read it on the chat that everybody enjoyed it. So looking forward to next Thursday. Thanks so much again. Thank you, everybody. If anything, just email us if you have further questions that could be maybe briefly addressed in the next session before we start, if you start exploring this and something comes up.
Thank you so much, everyone. Thank you, Anna. Thank you, Ken.
Thank you, everyone.
Pleasure.
See you next week.
See you next week. Thanks
See
so much.
you. Ciao, ciao.
Bye. Thank you.